video, we're going to look at graphing the function f of x equals cosecant of negative pi x minus 2. So what we want to do first is think about how cosecant is the reciprocal of sine. And so we're going to use the sine function to help us out here. We can also think about what's our a value, what's our omega value, our phi value, and our b value, and think about what all of those things do, how they affect the graph. First thing I want you to notice here is this omega value is negative. So remember, we don't really want that to be a negative. That omega value helps us figure out the period. So the period is 2 pi divided by omega. But talking about a negative period, we don't really want to think about that. I mean, I guess we could think about going backwards, but we want omega to be positive. So the way that we handle that is we use our even-odd properties. So the first thing we're going to do is we're going to factor a negative out of this business here, plus 2. Okay, and then we can use our even-odd properties. Is cosecant even or odd? Cosecant is odd, so let's move this cursor out of the way. Cosecant of negative x is equivalent to the opposite of cosecant of x. So we can take this and bring it out here, and they will have the same graph. If we graph f of x equals negative cosecant, we're going to get the same graph. Okay, so that makes our omega value now pi. And our phi value is actually negative 2 because of the minus. Remember the minus in this formula over here, this formula. So it might help to write it this way. Some of you don't need to do that, but so the negative 2 is our phi. So our period is 2 pi divided by omega, which is pi. So our period is 2. And our horizontal shift is going to be found by factoring out. If you wanted to do that, you could factor out the omega value inside these parentheses. So you'd have pi times the quantity x. I'm just going to write that as plus, and we're going to remember that it's minus and negative. It's too much writing. And then this would be 2 over pi, right? Because when you factor something out, you divide. So our horizontal shift is going to be negative 2 over pi. Okay, so here's what's weird about this one. We've got a horizontal shift in terms of pi, but we have a period that's not in terms of pi. So it makes writing the scale here very difficult. In this situation, I would say, let's go ahead and put this in a decimal. What is 2 divided by pi in a decimal? So just punching that into my calculator, I get approximately 0.6366, so say 64. All right, we're not building the piano here, as my father-in-law used to say. If we need super accurate decimals, we'll go to decimals. We're just trying to get a picture of what this graph looks like. So I'm going to round that to 0.6. So that means my graph is going to start at an x value of negative 0.6, or one of the periods, and then it's going to finish 2 units later. All right, so that's going to be at 1.4. Okay, so we're going to start one of the periods at x equal negative 0.6, and then we're going to finish at x equals, add 2 to that, would be 1.4. Okay, and then if we think about it, then the next one will start at x equal 1.4 and finish, if we wanted to graph 2 periods of this, at 2 units later would be 3.4. So let's set our scale to make those somewhat easy. Oh, let's see. I guess we could make this 1, 2, 3, 0.4, and then this would be -1. Okay, so then each of these would be like, right, 0.25, 0.5, 0.75 kind of a thing. So we're going to go ahead and graph sine f of x equals, let me do this in a different color. Ultimately, we want to graph the cosecant, right? But we're going to start by graphing the sine. Let's use orange. That looks like fun. So we're going to graph, say, g of x equals negative sine of pi x plus 2. And we're going to use this information over here to do it. So we're going to, sine starts at 0, and we don't have any up and down shifting. We don't have any vertical shifting, so we're still going to start at 0. But this time, we have a horizontal shift of -0.6. So instead of starting at 0, we're going to start over here at -0.6. Okay, and we need to finish at x equals 1.4. So we need to finish over here about 1.4. Then the next one is going to start at 1.4 and it's going to finish over here at 3.4. So there's going to be 2 periods worth. So let's just look at one period, which will be, you know, like from here to here. And we're going to break this down into where is it at its high point, low point, and back at 0. Well, we know with sine, it's going to be back at 0 halfway between -0.6 and 1.4. So we got to figure out what's halfway between -0.6, -0.6, and 1.4. So halfway between would be the average. So that's going to be 0.8 divided by 2, which is 0.4. So halfway between, let's see, that's 0.5, so say there's 0.4. And then halfway between 0.6 and 0.4 is going to be at its max or its min. Now notice over here we've got a negative in front of the sign. So instead of going up and then down, it's going to go down and then up. So halfway between -0.6 and 0.4, it's going to be at its minimum. So that's -0.2 divided by 2 is -0.1. Negative, so that's 0.25, maybe about right there. So that's going to be at its minimum, which is -1 because our amplitude is 1. And then halfway between 0.4 and 1.4, it's going to be at its maximum. So that's 1.8 divided by 2, which is 0.9. So x equal 0.9 would be about right here. That looks about right, right? And then it's going to be up here at its max of 1. Whew. Okay, so another way we could think about that is if the period is 2, then it's going to be 0.5 units to go 1/4 of the distance. So this is -0.1. So notice it's 0.5 units between -0.6 and -0.1. Then add 0.5 to get to 1.4. Then add 0.5 to get to 1.9. Then add 0.5 to get to 1.4. So you could also approach it that way. All right, so let's go ahead and put in the other. So if I add 0.4, I'm going to, the next period, the other important points. So if I add 0.5, I'm going to be at my minimum. That's 1.9. And then at 2.4, I'll be back at 0. And then at 2.9, I'll be at my maximum. And then we can sketch this in. Now remember, this isn't our final graph. This is our sine graph, which is going to help us figure out our cosecant graph. Okay, so the next thing we want to do is graph our asymptotes. Luckily, we don't have a horizontal shift to worry about. So we'll put in our asymptotes, and those are going to occur where we have 0. All right, I should probably use a line tool. We'll just see if we can do that. Okay, you put in the asymptotes. I'm going to go grab a line tool and put in some nice ones. All right, so now we have our asymptotes. And now we can basically draw in our cosecant graph. And just a word of warning, remember if you did have a plus b here, some kind of a vertical shift, that you would want to draw your asymptotes before you do your vertical shift. But luckily we don't have to do that on this one. We're almost done. Let's put in our cosecant graph and then go do something relaxing. How does that sound? We're going to put in our cosecant graph. Just going to be there. Ooh, that was a rough one. I think my upside down ones are prettier. Let's see if I can make a prettier right side up one. That's a little bit better. And again, if we wanted more detailed points here, we could go to Desmos and punch this in and use the tracer. But this gives us a really good idea of where the graph of this cosecant function lies.